this video, I'm going to be talking about the circle theorem that concerns angles in cyclic quadrilaterals. Specifically, I'm going to be talking about the theorem that says opposite angles of a cyclic quadrilateral add up to 180 degrees. Or if you prefer, instead of saying add up to 180 degrees, we could say opposite angles of a cyclic quadrilateral are supplementary. Now this phrase cyclic quadrilateral may well be new to you, but we know that cyclic means in a circle. We know that quadrilateral means a four-sided polygon. So all a cyclic quadrilateral is a four-sided polygon where all of the points are on a circle. So this is an example of a cyclic quadrilateral. All these points are touching the circumference of the circle. And what the theorem is telling me is that these two red angles here add up to 180 degrees, and these two blue angles add up to 180 degrees. Because this is a theorem, I ought to be able to prove this. And in fact, I don't need to prove both statements, I can just prove one of them, because even though it might not look like it, the idea that these two red angles add up to 180 degrees is the same kind of idea as these two blue angles add up to 180 degrees. So actually I only need to prove one of these, and that's what I shall do. Here we have a generic example, and just as I did in some of the other theorems, I'm going to add in some lines, I'm going to add in some radii. So I'm going to draw some lines that go from the centre to the point. Now I'm trying to show that this angle here and this angle here add up to 180 degrees. So I'm going to give those names, and I'm trying to show that A plus B is 180. Well, actually, this is going to be a lot easier than it could be, because I've already done all the hard work for this one. I did all the hard work in an earlier theorem that concerned points at the centre and the circumference. So using that earlier theorem, I can see that actually this angle here is the angle at a centre, and this angle here is the angle at the circumference in the same arc. So that means that this angle at the centre here must be twice the angle at the circumference, so this must be 2a. It needs to be twice a. Using exactly the same logic, I have an angle here and an angle here. This one here at the centre must be twice the angle at the circumference, so that one must be 2b. Now I know that this is a full turn. Angles in a full turn add up to 360 degrees. So that tells me that 2a plus 2b is 360. Well, if I divide everything by 2, I get that a plus b is 180. So there I very quickly got that fact because I'd already done the hard work before. A plus b must be 180 degrees.